Hey, what's up, guys? You've been asking, so here it is. It's about 3D printing and how to get started. So, I'm going to go over the basics of 3D printing, some of the things that you're going to need, and I'm going to walk you through how to basically build a print and print it. So, how a 3D printer works is it takes filament and it heats it through a nozzle, an extruder, like a hot glue gun, and it prints a 2D image thousands of times. So it's like a CNC or computer controlled hot glue gun. And in order for it to work, we have to give it what they call a G code. And that G code is a type of file. Over here on the right is the little box that plugs in, that has wires that come into the back of the back here. This box, you can control some of the minor stuff, like zeroing it, loading a file, telling it to print, stopping a print, pausing it, X, Y, Z, extruding, turning the fans on, some basic settings. So now that we know it kind of just is like a hot glue gun, the three things that we're going to need is going to be a printer, a spool of filament, and a computer that's going to run our programs. Because this little box on the right doesn't run the programs that we're going to need. This is what a spool of filament looks like. They come in a kilogram. They range 15 to 30 bucks. They come in these moisture sealed plastic wraps. You're going to want to keep those in there because they're hydrophilic. They're going to absorb the moisture from the air. And once it absorbs moisture, as it comes down, it'll boil inside the nozzle and it'll create pore layer adhesion and voids in our print. And it'll be a bad print. We'll also get bad edges. It'll be stringy on the sides and we just won't get the quality that we need. So keep them in the boxes and inside the packaging if you can. If you're using it and you don't use all of it, you're going to want to dehydrate it or keep it in a container like an ammo can or something like that to keep them from absorbing more moisture. You can put them in like I was saying, an oven beforehand or dehydrator. So now on to the next thing. We've loaded in our spool of filament. We got a printer. It doesn't really matter what printer you get as long as you get one with a heated bed. That's what I'd recommend. You get one with a heated bed, it'll usually print ABS. You can see if it says ABS most likely. This one's a Monoprice Maker Mark version 2. It ran me around 300 bucks. It didn't come with this enclosure, that little box here, which is a transformer just plugged in. And that powers the lights. And this is a controller that comes up and it has a little ventilation fan on the top for the enclosure. And I usually wrap this in a heated blanket. The reason why I built this stuff and I have a light and a little camera here I used to that would watch it is because what happens is because of the temperature difference, you can get poor initial layer adhesion on the very first layer right here. And the print won't print properly if you don't get that first layer down right. So that's one of the things that you're always kind of fighting. Something that you might use is like ABS glue or juice, watered down, milk consistency. And you would paint that on the bottom there where your print's going, and that would help it stick. You can also print on something like a raft. This is just a setting, and that would also create a flat surface for it to print on. You might want like some tools after, stuff to pry off your print after. That one came off easy. And the reason is because you can see a little warped. This is an ABS print. You can't even see the lines because they're so fine, but you can tell it's on a flat surface. And then that zigzag pattern, you can tell when it comes back and changes directions. It's a little thicker when it changes directions, so the wall thickness is if you do a solid print, this is a 20% infill, but it's sturdy. It'll flex though. Push really hard. It's just a little box that I built. So what you fight with on printing is that initial layer like I was talking about. You don't need to have all this stuff, but if you have an enclosure that you can keep warm, you have that heated bed that you can keep warm, it really helps with mitigating a lot of the warpage and keeping a nice hot bed and a consistent temperature all the way around. So now we're going to go on and we're going to learn how to download a print, build our own, and manipulate a file into something that this will accept. So I said that this needs G-code files. I'll take you over here. All right. So we have a computer here with a couple programs open. That camera, like I was talking about, just a little something you guys can see. So we can download the 3D files from different websites. Some of the websites we can use is going to be Thingiverse, GitHub, Odyssey, ControlPew, and there is a lot of others that I left out, but those are the, some big ones. And you can download not G codes, but you can download 3D images from them. Those 3D images, the common one is going to be called an STL file. We can also build STL files in a program like SketchUp. And once we build that STL file, we would take it then into a program called the slicer, like Kira. And Kira would then create layers and convert that STL file into G-code. So there's multiple steps that you have to do. So we've built our file from, let's say, SketchUp. This is the pro version, but you can download the free version too. This is just a template that has a basic profile that's in millimeters. To draw something, let's say I want to build that box that was on there. It's going to hold this. And so I would measure that with calipers or something like that. And I would take and draw a line here to that length. It was 110 by if you see here on the bottom right, I typed 110 and you can see it pop up right there. I'll click enter. I would go up 30 and I would go this way and just back down. And I've created a 2D image. I would extrude it or push pull it up 60 millimeters. I would offset this from that wall 5 millimeters. Oops, I didn't do it. And then I would take that 2D image on the surface, the inner one, go down 55 millimeters, and now I've created my box or my 3D image. And I can save this as an STL file by going here and clicking export 3D model. You see down here it says STL file. A bunch of others you can save it as. So we built one, and we can also download one, like I was saying. Some of the download ones here are in, look like this. You can see like little speed loaders I have. Little loading trays. If I then open up my slicer, Cura. So let's say either one I downloaded the STL file. The first thing I'm going to have to do in Cura is load in my printer. To do that, it'll load in every time, but after you need to do it one time. I would go up here and I'd click printer, add printer, and then, there's a bunch here. And that would preload my printer. If it doesn't have it, it'll preload the profile. I could also manipulate the settings manually by clicking machine settings and go in here and enter all my printer settings that come with the printer. Should be in the manual. That will give you a basic build template and allow you access to these settings over here. And also these different plastics you could see that you can print with mainly. So we loaded our STL file, this box, and it'll just show up here. We can position this around using these settings here, wherever we want. We have our printer preheating with ABS, so we're going to select ABS. And even though here it doesn't show all the different settings, you can manipulate a lot of them. So we'll select ABS. We want to just test this out. So there's 6 settings here. You could do a draft. This is like a custom one, so I would just select just a draft quality one. And then I would go through and just click I've messed with some stuff, that's what that was saying. If you have issues, you would go through and change these settings on the right. The ones that are here listed aren't even all of the settings. If you go in here, there's thousands that you can mess with. So many. Not thousands, but there's quite a few. And you could checkbox all of those if you want them to all show up, but to condense it, these are just the main ones that people mess with. You might want to change these settings if you have issues with sloppy corners, poor initial layers. You want to add that layered raft like I talked about. You could go down here and you can select the support. Maybe you could click build plate adhesion, raft, or brim and skirt. They're all different ones. Support is something that you might need. Let's say if this box was upside down, when it came up to print across that bridge, you would need something to help support it. That's just a feature that you don't even have to design in if you just select this. Sometimes you do have to design it in if it's really big areas. Sometimes not though. So one of the things, if you were to download like a file from Thingiverse or anything like that, it would tell you the material that they printed, and they might tell you the printer. So it'd be like ABS, I printed on this printer, and I maybe even printed this hot, or maybe not, fine quality. They might tell you some of the settings that they messed with if it's a really complex print. So this is Thingiverse. You could print a paint can. And when you open this up and download the files, that was at the top there. You'll see, yes, they used or recommend using a raft. No supports. PLA. 90 minutes on low quality. So that would be the downloaded one. This is the box that we made. So we'd have to kind of be like, oh, I don't know, we'll go with just this. And what this program does is takes that STL file and converts it into the G code with all these different settings that you can change. You can even look through the individual layers to see how it would look on the 300th layer. You can see why it's going to take so long to print. So all of these settings on the right are going to change the time that it takes to print on the bottom. Each of these are going to have an effect. Some of them will produce a stronger print, but that will most likely increase the time to print. So I call this one Draft Pro because it goes pretty slow. And then we can click Save to File if we have just an SD card, take it over there and click Print, or we can directly print from our computer if we hook it up via USB. So this is called the slicer because, as you can see, all those layers that it does, and it converts that STL file into G code by slicing the image, that 3D image. I'm trying to think if there's anything else that I could show you guys. I know you don't really need to adjust these settings, but I just wanted to show you that you could. And if you ever have issues, you can look more stuff up. But that's just pretty much how you get started. You would have then the G code on your USB. This is an STL file that I downloaded. You can just preview them in Preview. That's all this is. And you can see, oh, I might need supports then, for just right there or something like that. And that's it. Hope you guys enjoyed the video, and if you guys have questions, please let me know.